Hello everyone, this is Stockhouse Ikim again. I've had a lot of questions on the last news release based on some of the things talking about section and dotted lines off section and what does that all mean in 2D space, 3D space. So I thought I would go through the news release that Peregrine Diamonds just released, but more importantly the diagram that they've sent and the information that they've included on it, so we can have a look at kind of what does that mean in real 3D view or whatever you want to call it, to give a bit more understanding of what it means. Because when they say the deposit widens at depth, well, where does it widen and what does that mean exactly? So hopefully today I will show you and you can get some understanding of that. So right now I'm just recording my screen here, and this is the press release that was released yesterday. And basically they disclosed 3 new holes that they've drilled over the summer, in addition to the one that they drilled in early July. So what we want to focus on for this video cast is this screenshot in the middle here, where they have the hole from earlier July, drill hole number 33. They have 39 there, which has not as the same relevance as what we're trying to look at on this section as the 38. So 38 and 33 are the 2 key holes here. You see some red lines here, some solid green lines, some dotted lines. What does it all mean? So first we need to look at all the information that we have here, and the key is actually at the bottom here. So they're talking about 20 meter west-east section at 619,400 meters east, 713,5140 meters north. That's coordinate section looking north-northwest. And then it says dotted drill traces are off section. So there's a bit of information here. There's the 20 meters west-east, coordinates looking north-northwest. Dotted drill traces are off section. So we have some information on and off the section, but what does that really mean? And then we have a legend here and all that good stuff. So this confused me at the beginning, because usually a west-east section, by defining it a west-east section, you're usually talking about taking north, east, southwest, and you're just doing a directly 90 degree to the north, west, east section. But then it got confusing when they gave this looking north-northwest. That didn't make a lot of sense to me. And then if you're doing a true west-east section, you actually do not need an east coordinate. So it got me thinking, and then I kind of figured out what they've done is they've taken a section that's relatively west-east, but it's not quite. It's actually looking north-northwest, and a data point on that will be this coordinate system. So how do we look at this in the body? Well, we need a chart, an image showing the layout of CH6 in X and Y format, to get an idea where are we looking at. So if you pull up the technical report, and this is on page 68 of the PDF, it's figure 10.1, and it's a plan view of drilling to date at CH6. So this is kind of looking top down over the body. And what we have here on this chart is they've taken these images here, these curvy lines, and kind of predicted exactly where, or approximately where, that pipe boundaries are. So the first one, the solid black line, there's estimated surface expression outline. So this we see goes around like this, and that's kind of the shape at surface. And I believe that's to be about 1 hectare in size, but obviously it's not a square, it's not a circle. It's a multi-shape polygon device system, whatever you want to call it. And then they've taken another 120 meters down the body and put what they think is going to be the outline of the kimberlite pipe. And it kind of goes into a long, oblong, squished oval, whatever you want to call it, shape. and as you go down, this is kind of what they've modeled at. So now how do we take the data that they released yesterday and apply it to this map? Well, first we need to get this into a paint or program, so we're going to start drawing lines on it. So I will do that. Alt press screen. I'm going to use 3D Paint, which I've just started using. It comes in Windows 10 and has a bit more tools than just regular paint. I'm going to paste it there. And so there's my screen. Now I want to crop it. So I'm going to select crop. And let's see. Okay, let's just select this and crop. There. Now the zoom's at 74%, so let's increase that. Whoa, that's a little bit too much. Okay, that's a good point of view. So now let's get some points going on here. So what's the first thing we know about the news release? Okay, so this coordinate system here, 619,400 meters east, 713,5140 meters north. Okay, so 619,400. We go here. You can see the coordinate. The texture is not that great because this is an image plucked from another image. But basically, it's going to be along this line here, and then we have 713,5140. So that's 150. So it's going to be right about there. So it's right where this DD30 text is. So maybe I can just write something there. Maybe a little X there. Okay. So that's where the coordinate system is. Now, what do we want to look at? Well, we know that the section is looking north-northwest. Okay. So go back to that drawing. So basically north is straight up this diagram. Okay, so if we just to give a hint, let me see what else I can use here. Let's see what this does. This is a crayon. Okay, so that's north. Ooh, look at that. Okay, let's do that. I learn as I go. Okay, let's try a pencil. Let's see how this works. Okay, that's not bad. So that's north straight up. So northwest would be like that. So north-northwest is going to be in between like that. Okay. So that's kind of the angle I want. I'm going to change over to using lines. Okay. So it's going to be kind of like that. But that's kind of where we're looking from. So if you're going to be a little person here, you're going to be looking that way. So the section is actually going to be perpendicular to that. So the section is going to be more like that. Okay. So now we know basically the angle of the section, and we have a data point on that section. Now we can draw where the section goes through. And this is just, I got to select the line, select the line. That would be about right. Let's go with that. Okay, so there is your section line. Okay. Now, what else do we know? Go back to the news. So now I was talking about a 20-meter west-east section. So the section itself could be, well, this is the intersection. So anything that falls on that line could be on that section. But you know, a lot of these information, these holes are, you know, just off the section. So what they do is they give this a bit of a width. So we know that 20 meters is about basically from there to there. I'm going to assume that what they mean by 20 meters width is it's 10 meters on each side of this section line. So we want to get a line that goes basically from here to about there. Okay, so we can do one on each side. These are all just approximate. There we go. And let's do one more. There. Okay. So now we know, if I draw a little arrow here and I rotate it, if you're looking at the data, this is the angle you're looking at, and you're looking through this section here, and that is trying to emulate this. Okay, so what do these dotted lines mean? And then we have these solid lines too, right? So, okay, so first of all, you'll see that diamond drill hole 38 is completely solid, okay? And we know it comes from the east side, and it ends up on the west side of the pipe. And what else do we know from diamond drill hole 38? If we go up, it says an azimuth of 258. The inclination is minus 60 degree. The 60 degree you can tell by the shape right there. But what does azimuth mean? So we got 258. So go back to here. So north is an azimuth of 0, and it goes all the way around 360 degrees. So we have an azimuth of 258. So if I know west is exactly 270, then 250 is going to be like that. Oh, wait a second here. It looks almost identical to the section that we're getting at. So if we wanted to draw approximately where this is going, we could map where that diamond drill hole is. So we know it kind of starts over here, kind of where this is, where the surface is over. So we know it starts over here, and then we know that it ends over here. So we can kind of guess where it ends. So, oh yeah, look at okay. So this is where it gets confusing, because now you're thinking, oh, look at the surface topography here. That's pretty narrow, right? But they're saying, oh, the surface maybe is even bigger than just below that. But the reason for that is because the section on surface is going through this narrow area. It misses this whole thing out here. Okay, so we have to keep that in mind when we want to try to plot this dot versus that shoulder of the pipe. So if we assume that this is the shoulder here, we'll probably put it somewhere over there. So let's see what we can draw now. You know what? I'm going to go back to drawing X's. Oh, not that one. Let's go back to the original one. Okay, so it's going to be somewhere over here. It's going to be 38. Okay. And let's draw a line from here, but let's just do a little offset there, just so we can not see it right on the same lines. It probably comes here, and let's change the color. Okay. So that would be diamond drill hole 38 there. Okay. Now, let's look at this information here. Okay, first of all, let's talk about the dotted lines. So this is on section. So that's why we could put it on here. So we know that it's within this 20 meters. This entire drill hole is within that 20 meters. Okay. Now, if we look at diamond drill hole 33, it says it's off section, and then it gets on section, and then it gets off section. And based on the information before, diamond drill hole 33 was basically a pure west to east diamond drill hole. So if we want to plot it up as an east-west hole, we can go like so. I'm guessing a little bit, but I know it's going to be off section for a little bit and then on section. So let's first of all do a little X. So let's just assume it's right about there. Okay. And then if we do a line, we can do a line across like that. Okay. And I'm not sure exactly where it is in the north, the coordinate, so I'm just guessing right now. Let's change the color to something else. Change it to blue. Okay. So this is now diamond drill hole 33. Maybe we can write some text here. Let's see, 38. Oh, that's pretty big. Make it this big. Oh, we can do it. Sure. And then let's do another one. Text. 33. Oopsie, what's going on? I'll pick up the whole thing. Seem to have lost that. I will just delete it. 33. There we go. There we go. Okay. So basically what's happening is this drill hole, we want to look at the data on this section. So when it goes off the section, you can see it's not within that 20 meter spacing. So that means that this, when we see it on the section, means that it's off section. So you can see 33 is off section, and then it's within the section, and then it goes off section. And maybe I've driven this out too far, but we'll leave it. That just gives you the concept. So now if we go here, we can see that it's on section, and it's off section, then off section, and then on section for the rest of it. And that's exactly what we're looking at here. Actually, it should be probably a little bit further up. Oh no, not necessarily. So now, if we look at hole number 30, okay, so if we focus on the 125 meter model here, right, and we see the intersection at the section right there and right there, and the way they've interpreted it, so let's assume 125 somewhere around here, on here. They basically said, oh, it's just going to go vertical. Oh, it's just going to go vertical, right? But now we know that diamond drill hole 38 actually, when it's down at 277 meters below surface, it actually hits the ore sooner, or the kimberlite sooner, than just this vertical diagram. So if we take that, the drill hole, the model said that down below it actually was supposed to be there, but in reality at 250 it's actually further out. So if I take my drawing, and then let's assume we're drawing a new shape based on the 125 meter, but we're doing it 250 or below. So what we can probably infer is that the ore body on this side maybe spins out a little bit more. So we get a tiny bit of a width here increase based on that drill hole. Okay. Now it's the same on the other, on the west side. You see the interpretation is pretty much straight down, which not only affects your inferred resource up here, but it also affects your TFF here, TFFE, which is tonnage for future exploration. So if we go back to here, on section here, you can see it goes down to there. It's outside the body, outside the model, and they even have a little bit more further down that goes outside the model. So where is that line? Should you do it here, here? You definitely should not do it where they're modeling. It's definitely further out to that. So if we draw a line, you can see where they modeled the drill hole, but the reality is that maybe the ore body goes out to there at lower down 250 and below. But now we have other information too. We have this drill hole number 33 as well, and we know that it hits further out the model at 200 megabits, yeah, too much IT stuff, 200 meters below surface. So that's 35 meters. So we can go here, and we know that this here is further out as well. I don't like that. Let's just do a simple line. Okay, so now at depth, and this isn't just depth, this is two informations of depth, because we have this one up here at 235, and then we have this one down here at 442, and this one at 485. So we can pretty much now remodel this to go further out for that entire section. So all this modeling was basically a model, and that's what it is. And models need to be redone. So if we take this line, let's draw, I'll change the color in a second here. Basically, we can assume that at depth, we're going to get something like that. Okay, actually I'm going to do that. I'm going to do a different color. Let's do it this color here. So this is where we're going to assume that it grows bigger. And that's not just down at 500 meters, that's even at 200 meters. So we know that this model at 125 may be correct at 125, but to apply it straight down all the way to 500 is wrong. And that's what this drilling is proving up, that the body expands in size a certain area. So when you come here and look at this drawing and say, oh wow, the west side of the whole kimberlite body expands by 35 meters, that would be wrong terminology to use, because then you'd be applying this whole west side at 35 meters, which would be significant because this width here is the narrowest part. It's longer north-south and smaller west-east. So if you were to increase the width 35 meters on the west to east, that would be a very significant increase. But what you are doing is you're basically the south half of the body, you are increasing the width by maybe 35 meters, which is very significant. So maybe this, surface it's 1 hectare. Maybe it goes down to 0.9 to 1 hectare, and maybe deeper it regains its kind of 1 hectare status. That's just, unless you got this loaded into a 3D software and you can run volumes. We're all just kind of guessing on what exactly that means. But we know that, the model, the very least, meets expectations of the models. And this drilling shows that it's actually exceeding what the model predicted. Okay, so I'm going to quickly show in 3D space. There is one drawing that I have here. Okay, and I have it written down. So if we go to the PDF right now. Okay, so this is the main working diagram we had, but if you go to page 52 now. We're on 68. Excuse me while I go through this. Okay. So you go through all these models, and some look east, some look west, some look north, some look south, some look northwest, as we just shown. Where can we see where this expands? Okay, so this one is a very good indication of what we want to look at. So if we want to look east, let's looking east. So basically on this diagram, we're going to be looking from here to here. Okay, So if we're looking east, then this is the west side of that diagram, and this is the, looking east, this is the left side of the diagram, and this is the right side of the diagram. So let's go back to that 380 image and look east, and then we want to focus on the west side, and we want to focus lower down, 200 meters and below. Okay, and if we go there, we're looking east. Now you see, this is the area we want to focus on. And as you see, there's not a lot of drill holes between, this drill hole on the right and this drill hole in the middle. So they've done a lot of modeling on very loose information. So they've connected this dot here and pretty much connected it right there. But in reality, is this blows out a little bit. Let me just print screen this so I can write on it. Paint, 3D paint. Oh, it's doing a new one. New. Oh, it wants me to save it. Okay, let's save it. Okay, PGD plan view. Okay. Okay, so I plotted that. Go. Select. And crop. Okay, let's zoom in. A little bit too much. Okay, so this is 380 meters below surface. This is 260 meters below surface. So this whole area below is where it's now predicted to expand. So their concept of doing this long elongated oval thing, and if I just plot it like that, probably is now more like that. Oh, my artistic ability amazes me. Not. So this is what we're getting here. So they've just expanded out this corner here, and that is what we see. Of course, now that drawing is open. I'm not going to save that one, so I will just open that up, and that is what we see here. Now, the kicker with the diamond drill hole 33 is at the end of that hole, they ran into some brand new material. Somewhere out here. Was that, well, technically it was at the end of the hole, but my hole might be a bit too long. And it might be further up. So let's say if it was right here, and that was fairly deep. Where is it? It's right here, and they've acknowledged that this little tiny green spot here is kimberlite that they can't directly correlate to CH6 signatures of their of the kimberlite that they found, and they don't know a lot about it yet. So I don't know if diamond drill hole 38 was hoping to intersect something that goes up here or not, but it did not. So this is a mystery now. They still need to figure that out, but that may not be achieved by this program, or it may be. We'll see. But anyway, the most critical thing is adding more carats and expanding this kimberlite pipe, which they didn't expand. This is what the pipe does. They're just trying to de-risk and get more information from the pipe so they can add it to the economics in a relatively within a certain confidence, in this case a PEA or an inferred status, and that's what they're trying to get. So the focus has been on this. Now they did drill another hole in that news release. The diamond drill 39 is the one they just blasted right through what they assume is the high grade kimberlite, which is the 4 carat per ton plus kimberlite. So they can add that tonnage, and it looks like it goes down to, the body. They went down all the way to 532 meters below surface. This is great news for MPV and all that good stuff. So this was drilled at an azimuth of 200 minus 83 degrees. So that was near vertical. 90 degrees is vertical. Azimuth of 200. So what does that mean? And this is the section. You see some of it goes on the section and some of it goes off the section. So if I go back to here, azimuth of 200 would be, so if we're looking all the way down, it'd be 180. So it's actually 200. So it's actually going kind of at the azimuth of the body here. And if I were to plunk it up, we know that it goes near the center, or a little bit to the left of the model, and it starts. I'm going to interpret this as starting at the north of the section, and then ends at the south of the section. So we're going to end up with, put a little line here, probably something like this. Let's thicken that up a little bit. Change the color. Okay. So that may be too much. I don't know. Well, it's a long hole. So 7 degrees off vertical will, after 500 meters, will travel, and that's where we see dotted lines. Then it's on section, then dotted lines, and that exactly is what we see. One question you may have on this, drill hole 33 is it looks confusing because you have this, this green intercept here, which we assume goes like this, and then we have this waist thing. But you have to remember this waist intersection at, from here to here is off section. So you got to plot it somewhere over here, where we can see maybe we've tightened it a little bit there. So you can't just it's actually quite far off section here. We're looking at the center, and then that goes off section, and that's where we can see the waist, because it's going to hit the boundary over there, and that is why we see that. So this is diverging away from this drill hole. So this drill hole is on section. Let's say it's right at a 0. So we know this waist data is at least more than 10 meters south of this hole. So that's why you can't just assume that this intersection is hitting the same thing, and they're not. They're at least 10 meters, if not 15 meters away south. And because the ore body drifts from the northeast to southwest, the further you go south, you're gonna hit that pipe a little bit, the end of that pipe wall sooner, and that's exactly what we are seeing. Now there's one other hole talked about in this press release, and it's a drill hole 36, which was done with a vertical HQ diameter hole. So that's the larger diameter hole, which they also use for geotechnical information, because it's going to give you a bit more better quality information for geotechnical analysis. So they drilled this in the north side of the ore body, and they intersected kimberlites from 4.5 to 300 meters below surface, and then they went to 378. So they went an extra 80 meters down before it was terminated. Now why would they do that? They've determined that confirms that the north portion has a southward plunge, and we can see that right now. So we have the outcrop here, and this is the north thing. So on the in 125 meter, you can see that it plunges to the south. So even deeper, it's going to plunge a little bit more. This over here is probably going to plunge a little bit more as well. So they basically drilled a vertical hole somewhere in here that probably, I'm going to guess, somewhere in here, or a little bit over, somewhere along there, so that they can drill. They've stayed in kimberlite through to 125, and they've stayed in kimberlite all the way to 295 meters, and then they hit country rock or waste rock. And one of the reasons that they would have kept drilling is, and probably the only reason, is the geotechnical information that they get from the hole. So that will help. It's a bit deep, maybe not as relevant for the open pit, but if it's similar to the other core higher up, then they have more data set. But also helps with the geotech when they do the underground ramps and all that stuff as well. So it's still going to be a net gain to the project. More geotechnical information you have, the more realistic you can do on pit walls and things like that. So it's good information to have. What else? So they also found in this hole, so if we go to hole 36, it also hit something called Kim G, which is a new subunit from 150 to 190. They also drilled this hole to convert TFFE between 260 and 380. So they must not have been completely comfortable with that northeast, the north boundary, where it is and what the tonnage and volumes are. This is interesting, the 149 to 189. And they seem to indicate that Kim G can be considered a variant. They're calling it a variant of Kim L. And Kim L is the main kimberlite there. We have carat values for it. So if they include Kim G within that, they might be able to use the carat value and then get its own grade based on the caustic analysis. Now I suspect possibly that there's the Kim C, which is somewhere in the north as well. If you look at some of the diagrams in the technical report, if this Kim G can take away from some of that Kim C, that would be great news, because Kim C does not have a carat value and is not directly related to the valuation of Kim L. The populations of the diamonds and the stones and the quality themselves are different enough that they can't assign a value from Kim L to Kim C. So if this Kim G takes away from some of the Kim C, they can get some of those economics into the study quicker than they would if they have to wait for some large diameter drilling of the Kim C material. So that's good news. And I think that, and they talk about Kim G, airfall, textural variant. I'm not sure about all this information. All I can confer from this is that it's a variant of Kim L, but the grades might be different, and they're going to do caustic analysis, I imagine, on that portion to see how it relates and what kind of grade they can get out of it, whether it hits the 2 to 3 carat per ton, or it goes down to 1 carat per ton, or it goes up to 4 carat per ton. They won't probably know until they do the caustic analysis. But right now that material is considered waste in an open pit. So if they can assign a value, that takes away from some of the waste and helps the strip ratio in that regard. So I think that's about it. Again, it's just looking at all the information one by one and what does it mean. So I hope I gave you guys a bit of an understanding of what it all means. To me, the fact that they've gone down to 500 meters, 532 meters below surface, opens up the door for the next phase down, which is going to be, from 500 to 750 meters. If it doesn't, narrow and it actually expands a little bit in this area, that's a good chance that it'll continue down. Something that, we had the odds that it continued down to 750, we didn't know at all. But now that we know it goes down to 500 meters below surface, the odds are good that it at least expand a bit more, and they'll add some TFFE, maybe 100 meters worth of TFFE below these holes, and they'll just model it pretty much vertical walls again. So that'll give some hope for more potential in the future. Anyway, I hope you enjoyed this, and I will see if I can find my off button here, which is nowhere to be found. There it is. It's recording at 40 meters. There, I got my device. Sorry about that. I just had to find the off button on that. Not sure what pointing up, so hit